Welcome to Math Minecraft Computers episode I36, where we will build two registers on a bus in Logisim in Minecraft. Well, let's start in Logisim. Okay, so here we have, I've opened the file we created last time, the register that is made of 8 D-type flip-flops, D0 through D7. We have 8 inputs on those to allow an input into them. We have a write and a read to allow us to write to the register. When that is turned on, the clock clicks. Our value stored in D0 through D7 input pins gets moved into the actual flip-flops. And then, of course, read sets these controlled buffers to turn on the fact that the output of the Q is then going to the output pin. So that's the register we created. I'm going to click right here with right click, say add circuit. I'm going to create a 2-reg circuit, just like this, and say OK. And then what I'm going to do is I'm going to create an 8-bit bus. We've done this a lot of times, so you don't need to watch. But the only difference is I'm going to go ahead and choose an output and put an LED here on the bottom. So I'm going to copy this 8 times, and we'll be right back. Okay, there's our 8-bit bus with an output down here. When I go to simulate mode, you can just see that the LEDs will come on no matter what I put on the bus. Okay, now as you recall, to get a register, we simply click here and we drag over to here, and here's our register. This is the external representation of this circuit. Remember, we go here, and there's what it looks like. That's all of our pins labeled. We'll go back to here, back to our 2 register, and we'll start wiring this up. Here is D0 through D7, and we simply make those connections straight over to the bus to be able to input from the bus to here. All right, now we do the same thing with the outputs. The outputs starting with D7 here, so I'm going to do them in the opposite order. They'll start on this side and work their way back. Okay, now everything is red because this is initialized. This is uninitialized in here, so the value that's in this is unknown. So since it's outputting the bus, everything turns red. Now what we need to do, of course, is we need to create 2 pins over here for inputting. These are going to be our write pin, which is going to come from here up to there. And we will label that as write. And we'll have another one right here that will be the read. And connected into the read right here, as you can see, this is the read if I hover on it. Okay, now if I click on this read here, you'll see that I don't get an output from the register unless the read pin is set. I need to have that label on the east so we can see it. And then the last thing, of course, we need to go into wiring and grab a clock, because we will need a clock to be able to set this value. There's the clock. Okay, now, we basically did exactly what we did last time, except that when I have a value on the bus, for instance, let's just put the first and the last bit on, D0, D7. And now if I click read over here, you'll see you get an error. Once again, we have no value in that. So let's go ahead and say write here. That means we're going to write the value that are on the pins here and here. And we're going to click the clock. Turn off the write, and now when we do the read, you'll see that we don't have the red anymore. We put a value in there. But as soon as I change this value and I click this, you'll see we get a red on those. The reason why is we have a 0 coming from the bus, and we have a 1 coming from the register. So it tells you there's 2 opposing values that are occurring. So which one is it? How do we solve that? Well, just like we put the controlled buffers on the output pins here, we have to do the same thing to our bus. So let me move this down. We're going to now grab out of the gates the controlled buffer, face it south, and put it in place. And that is how we solve that. So I'm just going to move all of these down and get that done. So now all of these are simply connected together. We're going to bring these over to here, and I'm going to put a pin up here. It's going to be an input pin. It's going to be labeled bus read. And that will, of course, put a signal to read into the controlled buffer, and we just connect all of those to that same wire. Okay, now that I have that hooked up, I can either choose where I want to output. Am I outputting from the register over here by clicking this read, or am I outputting from the bus here? So obviously I can put 2 different values. Let me put this value, the inner 4, it's 2 through 5 on. And you see no values here because we have not output anything. I select this that says read. That then says we move the value that are on our switches to the bus. Now I can do whichever one I want. You see there I have stored first and last on, 0 and 7. And here I have stored the other. Now all we need to do is put a second register on here. So again, I click here and bring over to here. Now this time I'm going to connect the outputs first. I'm going to line them up this way. This is actually 7 here, and that goes right onto that output pin 7. And we're just going to do that straight across here. Actually, I'm going to move it up 1. I think it'll be a little clearer if I move it here, and we'll connect it. Yeah, I could connect it anywhere on this wire. I could bring that register down here, but just for simplicity, I'm going to do it right there. And then these all connect up directly into here. Remember that this is output 0 through output 7 down here. So I'm just connecting them up to the proper wires on the bus. Then we do the same thing over here. So I'm going to do a little different. This is actually, remember, D7. This is the input. So I'm going to connect it to that wire. Can we do that? We shall see. Okay, now all we need to do is get these remaining connections that we need over here copied for this version of the register, the second register. So we connected our write and our read again. Get that correct. And then of course we need our clock. We use the same clock because we want them synchronized together. And that is where we are for this particular version. Now you can see that I can have a value here, which is certainly uninitialized. So let me put a store in that. What would I store in there? I choose what I want to read from. I want to read from the bus. I want to put it in this, and then I click the clock. Just like before, now when I click read, you can see that I've got this value in this register, this value in this register, and let's put a completely different value up here on the bus. And now we have 3 different values. Out here, out there, and there. Those are our outputs. Now the question is, can I put a value from, say, this register, which you see is the 4 inner, to this register? Certainly, where do I want to read from? I want to read from this register. That's now on the bus. And of course, I want to write whatever is on the bus, and I just click this. And now the 2 registers will have equal values. You can see that no matter what it is, it's there. So I choose the bus, for instance. I choose the write here. I click the clock. And now I've stored the new value that is on the bus in this register. And that's all we have to do. Now, of course, the difference is I would go ahead and enable ticks. And while that clock is ticking, as long as I don't have any write or read enabled, I can put whatever value I want here. Let's do the 2 outside, like this. You can read it. It's no problem. It hasn't been written into any of these because I haven't actually clicked a write. But as soon as I click a write and the clock clicks, there. Now I've stored that value in that register. So there it is. That's all we have to do. To move from one register to the other, I choose which register I want to read, which register I want to write, and I wait for the clock to click. It's right there. It's the leading edge of the clock that does this. And now you can see that the registers have the same value in it. Or maybe I want to go from the bus back into this register. So I read from there, write from there, wait on the clock. And there it is. That's all we're going to do now in Minecraft. So we are back at our 8-bit bus. We built our 2 registers. Here's our D-type flip-flop register, which is larger. Here's our simplified register, which is an SR latch with a monostable circuit attached to it for the enable line. But we're going to work over here today, and we're going to bring this particular connection from the output here all the way back to the bus, just like we did in Logisim. So what we're going to want to do is we want to have that connect right back here on this side of the repeater. And so I can do that like this. This will be coming up and up this way. Now what you can't do is you cannot have a block on top of this torch. If you do, that messes that up. So you have to set this up so that it comes. And I only want it to be high enough to come over this. You see I have a lane right down here that is perfectly high for where I want to come. So I want to come at this height. I don't go over any torches this way. And I'm going to come down to here. Now what we want to make sure we do is when we get powered here, we want to make sure that we're powered up. Okay, we want to bring the output of those and we want to connect it here. So for temporary, I'm going to put this down. I'm going to put a slab there, and then I'm going to bring these blocks all the way back like this. And we'll hook it up to our slab. And then we need to put our wire back there, of course. Now we want to see where we lose power, and it looks like we lose power right there, so I'm going to put a repeater. And then we're going to bring that all the way back here and see if we make it all the way back to the line without another repeater. Problem is we do not. You can see we are one short of doing that. So I'm going to have another repeater in here. It really doesn't matter where I put it, but we will start with this right here and show you what we can do. We want to be able to turn this on and off, as you remember, with a switch. Our input's eventually going to come to here once I get it powered. But what we want to do is we want to come back in front of this and remove this piece of wire, just like that. Let me show you what you can do. If I put a block there, you can see that this gets power all the way back to here. And you see I have one more. And the reason why is because this opaque block is strongly powered by that particular thing. I can put other blocks here. For instance, if I want to put my light there, then I could see that the same way. But we can't use the light in this case because we're going to end up using a piston. So what we're going to do is we're going to put a block there to indicate that we are going to move that, and then there will be a piston here that is stuck to that. I need to come back here because what we're going to do is we're going to have the piston stuck to this when it's extended. So this is where the piston itself, the piston head will be here, and the actual shaft of the piston will be here. So the piston will be in this location right here. And of course, what we want is a sticky piston for this. And so the piston will be right here. There's the head of the piston, the shaft of the piston when extended, and then the piston. So let me get a sticky piston in my inventory. And then we want to activate it with a block like this. Put a block back here, put a torch on it, let it grab that. Now when we retract it, you see that has disconnected. So this is going to be very much like our power buffer. When this is powered, then we have a connection from the output all the way back to here. The last thing I just need to do is where to put my repeater. Doesn't really matter. Let me just put it right here. And so you can see now that I have got it repeated and it's going to the input of this particular one. If I take that out, I'll show you again what happens. You see my one has to actually go to there. So if I were actually close enough, one more back here, I would be able to do that. So I could move this up one notch and avoid all that, but this is fine. Take this off, and our output goes off, just like that. So that is actually we're going to do this. I don't need that. I need to be able to run wire into it and do that. So we put 2 blocks under this. I'll put a piece of wire on it. And now we can bring our connection out this way. And you see now if I put a torch here and run some wire, my piston is active or not. So this will actually be my control line that I will use all the way back to this location. That's how this will work. Now all of these will actually connect into this control line. So I'm going to get it that far, and I'm going to leave it as you see here. We don't need that block, and I'll put that back down. And we're set. And so what that does is that gives me a controlled buffer. Now I'm going to put this on all the other 7 bits left. I'm just going to do that by copying, and I'm sure you can do that without me. So take that as a test. You want to basically copy everything new from this block right here all the way to this block on here. Our height is the piston. That's the size we want to copy. See if you can do that. I'll be doing the same thing, and we'll see you in a bit. Okay, here we are after the cloning. You can see that I now have them all set up. You see I turned these all orange, including this piece as our connection. And over here we need a switch, of course. put that lever, say, right here. And then it is a control line, so I'm going to go ahead and elevate it on up this way. And it's going to connect here. And we'll turn it on. And with it on, I need to connect it in properly, which means I need to come down here, add a block there, and bring our power this way. There we go. And find out, of course, where it goes and get all of our repeaters in place. That is going to go ahead and switch that. So we'll leave that alone. We can do that. You can see this is coming back and it's re-enabling and powering this. If I turn this switch off now, you'll see that this is now enabling this. But I need to have my repeater in place here, which I forgot to copy. And that's going to go ahead and power our lines. So what we have to also do is we have to connect these lines into this. So the way I'm going to do that is going to come off of this and up and over right here. And then we'll just dip it down where we need it. So it's going to look like this. Okay, and it'll go all the way. Of course, we'll have to put our repeaters wherever we need them. It might be better to repeat up here, because that will get us all the way. So let's go ahead and get that done, and we will see you in a bit. We're going to bring this control line that you see all the way over. Only needs to be that high to get it up and over this particular piece of redstone. So that's what we need to do. Now we've got that copy. Of course, the other thing we've done is we've copied this connection to D0 for every one, because that's the one this was connected to. So what we also need to do is we also have to go back to here and make sure that we get our blocks properly in place. So all of these will come back to their respective wire, which you can always see exactly where that is going to be by doing this. All right, so there we go. With all these bits on, we now enable the output of the register, which is this switch right here. We're going to call this a read, and turn it on. Turn all of these off. So we have nothing on the bus. Got the enable off too, awesome. And then we turn this on. And you can see that these should now be inputting on the bus. So each of these wires should be powered. If they're not, you need to put a repeater somewhere up here. That gets wire 2 powered, as you can see. That's wire 3. 4, which is bit 3. Bit 4. Bit 5. Bit 6. See, this is not strong enough. It needs to be able to reach that repeater. You guess the best place to put it maybe is down here. But you can't connect, so it's back here. There we go. And that's all connected. You can see up here we're short because that wire is not connected, so it looks like probably, I don't like redoing the repeaters here. I'm just going to do it right here. There we go. And then finally, this one, so it's all the way back here. And same thing, you put it right here to make sure that it is on down the line power. So one last one here, you can see doesn't make it. We just need to find out where that is. That's going to be way up here by where we connected it. So here's 0, 1, and 2. And it looks like to me the one that is off further down the line is right here. So we hit 0 how far? 2 spaces. I don't think this will do it. Here, we'll still be 1 off. Set the delay properly. Yeah, see, we have to have it somewhere back here too, because we have a repeater, so I don't have a choice. That just means we will boost it right back here. I hate adding repeaters on these lines, but that's what we have to do in this case. Now that register is hooked up, so we can now output it or not output it. You can see that it is currently storing all bits on, which is 255 in decimal. Turn that off. And the bus goes blank too. Of course, let's go ahead and enable this and set this to all off. As you can see, we've done that. Now to transfer, all we have to do is make sure we want to read. So let's put this value on the bus. And now we can follow the same thing this way. So we want to make sure the power now arrives over at this register so we can register. So once again, that means we end up doing probably a lot of these flip-flops because it just seems to be the way to go in Minecraft, is every time you make a change, you end up redoing repeaters. And that's fine. That's not a problem. So that is now, you can see the data is coming off of 1 and going all the way over to that register. And we're going to do the same thing here. It comes here. It's dying right here. We put a repeater. So now we just need to look at all of these lines and make sure they're powered. And that means the 2 registers are now hooked together. Keep in mind, once again, that register is all on, as you can see. This register is all off. We're outputting the register A onto the bus. We'll flip register B enable. And you can see this time we read the value from here. If I turn this off, now there's no power on the bus, and when I flip this, it will go back to 0 because we're now reading the bus. That is exactly what we want. Now, of course, the last thing I need to do is I need to do the same thing. I need these outputs to come back to the bus, and I need to make sure that they power the inputs to these. So the output of here is going to come this way, and you can see this way is going to be a little bit easier. I'm going to bring it over, and then I'm going to line it up and make sure that it attaches here on this side. I will use a different color for that because we want it to be a different control. So I'll get working on that just a little bit. But this is how it works. So let me pick a different color for over here. Okay, so what we're wanting is we're wanting this bridge to come in and connect in this location here. So this is where we're going to end up bringing the connection. And the output of this switch, this Q, is right back here. Okay, now with this switch, I want to actually bring straight down here. I don't want to get over that torch, and I don't want to get over that torch. So the easiest place for me to bring my connection out is either up over those or over to here and over on top of that. But I kind of like lining it up. So what I'm going to do is go ahead and bring this way. And then about here, start elevating it a couple, like so. This gets us above all the torches. We don't have to don't worry about hitting those. And then our output, as we did before, we just need to elevate it. So we'll start with a slab again. And we're back. So once again, let's turn all these bits on. Actually, we haven't turned on over there. Why don't we go ahead and enable register A, put it out on the bus, and then flip the switch. Okay, we've got it set now, and of course we have to start adding our repeaters. Get this all the way back to the other side. It goes this way. You need to turn this off so we can see which power we're getting. Because that needs to come in here and be able to power that line as before. So this is how we're going to do this particular one. Once again, I can copy that. And this time I'm going to copy it to this block right here. I'm not going to copy that one since I have to build these all anyway. So let me get after that. It's time to copy again. All right, so there we go. We have two registers. We have over here, register A. Over here, register B. The pink, rather sick looking control lines are the control lines for reading Reg B read. And there we have it. So now we have the registers back here, which are outputting back to the bus. We have the bus values themselves here. And of course, we have these. Now, the last piece that we still need to remember is we have to have those same sort of connections here, whether we're outputting on the bus or not. So we want to be able to put our value on here and then swing it to the bus. Okay, so I have got everything done. We have built our magenta lines for the control lines and the output from register A back to the bus. We have the orange ones for register A back to the bus. Over here is register B. So the registers now input from the bus and they output to the bus, and they have a switch that we can use to turn that data on or off on the read. So let's start by putting a value in register A. Let's do the 4 inside lights on, the 2 outside. What do we want to read? We have to put that on the bus. That's here. You can see down there on the end, we have the 4 inside and 2 outside off for each side. What do we want to do that? If we're reading from the bus has our value, we just click this. And you can now see that our register is exactly the way we want, 4 inside and the 2 outside off. Of course, we can now turn this off. The bus now has no value, and we can read what's in the register by clicking this. And as you can see, once again, there they are. 2 off, 4 on, 2 off, and it's on the bus. Let's put a different value in register B. Let's do every other. Like this. Where are we going to read? All right, we're going to read from our switches again, our input switches. Where are we going to write? Right here, we're going to enable register B. And as you can see, same thing. Now, what if we're going to go register to register? First thing we have to do is turn off the bus value, so there's no value back on the bus. It is empty, got a 0 on it. And we now want to say, let's go from register A to B. We want to read this value. Remember, it is 2 off, 4 on, 2 off. That is now on the bus. All we have to do is come over here and enable register B. And we now have the same thing. 2 off, 4 on, 2 off. So we've moved the value from A to B. Of course, the last thing we have to do is turn off this read. And we now have the 2 registers being equal. Let's do something different. Let's now put a register value on B. We'll do it the opposite. We're going to turn on the 2 outside and the 4 inside off. Now, what do we want to read from? We want to read from the switches. So we're inputting that to the bus, and we're going to write it here by simply clicking this, on and off, and there you have it. So the registers are now opposite each other. Get up here where you can see them. You see 4, and what's off there is on here. And now we want to move this time from B to A. So what do we want to do? Well, we don't want to import on the switches anymore. We want that off the bus. We want to read this and put that value on the bus, which now we should see down here when we look down here. It's exactly what we have. 2 off, 4 off, 2 on, 4 off, 2 on. And over here, all we have to do now, just to make it very clear that we're not doing anything with this value, I'll turn these off. And then we will go to here and we simply click enable to move that value to register A. And there you have it. 2 off, 2 on, 4 off, 2 on. So we've now moved a value from A to B, from A to the register, from B to the bus, and from B to A. That is it for Minecraft I36. Hope you enjoyed. Give me some likes, thumbs up if you want more. We'll move on next time to actually starting how do we do math in binary. And away we go. This is M. Roy, out.